I think that's all we're going to get for now. So we can get started. Welcome everybody to the Friday Compass talk. Today we are going to hear a talk from Xingchen Yang. Xingchen received his bachelor's degree in geophysics from the China University of Geosciences and a master's degree in civil engineering from Penn State University. He's currently a fifth-year PhD student in the Department of Meteorology and Physical Oceanography. And his advisor is Mohammed Iskandarani. I hope I pronounced that, Mohammed. And his research focus is on model uncertainty and quantification. And today he's going to give us a talk on loop current frontal eddies response due to initial condition uncertainties and the teleconnections between frontal eddies during loop current eddy shedding process. So with that, I will give Xingchen the floor, the screen.
Okay, thank you, Haley, for the introduction. Good morning, everyone. So today, I'm going to talk about the loop current frontal eddies response due to initial condition uncertainties and the teleconnections between frontal eddies during loop current eddy shedding process. So first, I'll introduce the background information about the loop current system. The loop current is part of the North Atlantic subtropical western boundary current system. It originates in the Caribbean and enters the Gulf through the Yucatan Straits and exits through the Florida Straits as the Florida current, and feeding the Gulf Stream finally. This intense flow is a dominant dynamic signal in the Gulf of Mexico, and it is crucial for many processes. For example, the biological connectivity between the Caribbean and the Gulf, and the pollutant transport, as seen in the Deep Horizon oil spill event happened in 2010, and also the management of numerous oil platforms. The loop current is highly variable. It can either present a retracted state or an extended state. When the loop current is in extended states, it sheds eddies at irregular intervals. So this plot shows the bathymetry of the Gulf of Mexico. The purple arrow shows the loop current in a retracted state, and the green arrow is averagely extended loop current. And finally, the red arrow is a loop current that is fully extended with an eddy shed. So the transition from an extended state loop current to a retracted state occurred mainly by the loop current eddy shedding. The loop current eddy might reattach and detach several times before the final separation from loop current. After the final separation of the loop current eddy, the loop current returns to the retracted position, and the loop current eddy drifts westward. So the loop current frontal eddy is one of the loop current eddy shedding factors that has been broadly investigated. The loop current frontal eddies are cold cyclonic eddies along the loop current edge with diameters about 80 to 120 kilometers. The loop current on the north side of the loop current frontal eddies on the north side of the loop current blocks the loop current from northern extension, and the frontal eddies on east and west side of the loop current play a role in loop current eddy detachment. So this plot shows sea surface height map for the Gulf of Mexico. We can see that there's a loop frontal eddy on the north side of the loop current. This one is preventing the loop current from northern extension. When we can also see two frontal eddies on the west and on the east side of the loop current. They are pinching down the loop current, and the loop current is nearly squeezed squeezed off by these two frontal eddies. The frontal eddy on the west side of the loop current is called Campeche Bank Cyclonic Eddy, CBCE, because it's formed over the East Campeche Bank. And the frontal eddy on the east side of the loop current is called the West Florida Cyclonic Eddy. It is formed over the West Florida shelf. So the loop current frontal eddies may split vertically into separate upper and lower layers eddies. The deep and the surface remnants from different frontal eddies may interact. For example, they can align to form new coherent structures. There are two major motivations of my current research. The first one is we need to better understand the loop current dynamics so that we can advance the ability to predict loop current behaviors. And thereby, we can provide valuable information for processes and activities that loop current has impact on. As I mentioned before, for example, the proton transport, the Deep Horizon oil spill in 2010, hurricane intensification, oil and gas platform operations, and so on. And my second research motivation is there exist many inherent uncertainties in the model simulation of the loop current system. For example, uncertainties in the parameterizations, uncertainties in initial conditions and boundary conditions. It is essential to account for different outcomes due to those uncertainties and quantitatively assess the uncertainties in the forecast so that first, the policymakers are able to consider a range of scenarios that reflect the uncertainties in the environmental conditions. And secondly, researchers can have better understanding of the model input impact on the output results. So my research goals consist of three major parts. The first one is we want to investigate the dynamical processes influencing a loop current eddy detachment by perturbing the initial condition. More specifically, we want to investigate how the initial condition perturbation would influence the loop current frontal eddy structure and consequently influence a loop current eddy detachment. And secondly, we are trying to use surrogate-based methods to link initial condition input and the loop current frontal eddy's output uncertainties in a probabilistic fashion to verify the surrogate-based method by comparing the output with observational data. And the last one is which we want to investigate the teleconnection between loop current frontal eddies originated in different locations. In other words, how the loop current frontal eddies at different locations remotely affect each other's development. So in the section of methodology, we use polynomial chaos techniques in uncertainty quantification to quantify the influence of input uncertainty on the model output. The task of uncertainty quantification includes identify uncertainty sources, propagate input uncertainty through numerical model to calculate output uncertainty, and determine input uncertainties that contribute major output uncertainties. The polynomial techniques, PC techniques in UQ is based on describing the dependence of a specific model output or model input data by a spectral series. This spectral series can be used as a faithful surrogate for the model. The advantages of the PC techniques include, first, the PC series replace the costly simulation with cheap surrogate counterparts. And second, the PC series can readily estimate the statistical moments analytically and also determine the sensitivity of the output to particular inputs. So we use the polynomial chaos technique to investigate the model response due to the change in the input. The model output is approximated by PC surrogate. This surrogate is expressed by a series of expansion. So here in the equation, the left-hand side M is the actual model output, which is a function of space, time, and uncertain input variables. This model output is approximated by a PC surrogate, MP, which is a sum of polynomials. So in the right-hand side, the M hat K is a series coefficient, is a function of time and space. This coefficient is estimated by minimized error norm. And psi k here is a basis function. It's orthogonal polynomial depending on probability density function of the input variable. So different distribution has different corresponding polynomials. So here we assume that our input variables are uniformly distributed and the corresponding polynomials is Legendre polynomials. So there are many factors that impact loop current behavior. The model simulations help us isolate those factors so that we can isolate the factors that we want to focus on. So in this study, the initial condition of high-count model is perturbed. So a scalar parameter is very easy to perturb. We just assign it with different values at different simulation runs. But the initial condition is not a scalar parameter, it is a field quantity. So we use Eof decomposition to compress the uncertainty in a field to a few random variables. To do that, we obtain these variability modes from a multivariate Eof analysis of 14-day data simulating high-count. This plot shows the SSH patterns of the first two Eof modes. We can see that both of these two modes are localized in the loop current region and associated with a presence of loop current frontal eddies on the east side of the loop current. And these two Eof modes, they cover 50% explained variance. And these two modes are retained as major uncertainty inputs of the initial conditions. So these two modes were multiplied by two independent stochastic variables and added to the mean fields to perturb the initial conditions. So in this equation, the left-hand side U here is the perturbed initial condition, and the U0 here is the unperturbed initial condition. Xi1 and Xi2, they are random variables to control the amplitude of the perturbation. They are also the uncertain inputs variables in the polynomial chaos approach. And Ui and lambda I, they are the Eof modes and corresponding eigenvalues. Alpha here is a factor that controls the size of the kick to the initial condition. So this plot shows the distribution of the 49 points marked by red stars. So the reason we choose 49 points is that the PC coefficients are evaluated with tensorized Gauss-Legendre quadrature rows using 7 quadrature points along each dimension. Since there are two random variables, so there are 49 points total. And this plot shows the distribution of these 49 perturbation points. So in the lower left side here, sorry, this one is the realization with most negative perturbation, because you can see here Xi1 and Xi2 values, they are reach the most negative. And the realization here in the center is a control run, which means there's no perturbation because Xi1 and Xi2 values, they are both 0. And the realization on the upper right corner is the realization with the most positive perturbation, because these two random variables have the both have the largest perturbation amplitude. So there are total 49 members of HiCom simulations, and we focus on these three representative realizations: the one with the most negative perturbation, the one without perturbation, which is a control run, and the one with the most positive perturbation. The output of the ensemble members is saved daily since May 1st, 2010, and it covers the loop current eddy Franklin detachment process. So we investigated potential vorticity anomaly to PVA to identify cyclone eddies activities, because in geostrophic balance, a cyclone is associated with a local maximum in potential vorticity. While the potential vorticity anomaly, PVA, it filters out the potential vorticity values when at rest. And the PVA can also be associated with strengthening or weakening of the cyclonic structure. There are 20 original HiCom layers in the model output. To reduce the complexity of the analysis, we reduce those 20 layers into 2 simplified layers. To do that, first we project the model outputs on purely isopycnal layers, and we estimated the PVA in each isopycnal layers. So the PVA is H, which is a reference depth, times the PV minus the PV reference. And then the second step is we examine the PVA signal of the loop current frontal eddies in each layer to identify the layers that have small vertical PVA gradient. So we group together those layers which have similar continuous PVA patterns. And through this method, we identify a 2-layer structure. And finally, we are able to reduce the original 20 layers to 2 simplified layers, with the loop current frontal eddies on the study are majorly in the upper layer, which is about depth of 800 meters. And then we estimated the PVA in the simplified 2-layer system. So I group my results into 3 parts. The first part is the initial conditions impact on the loop current frontal eddies. So this plot shows the Pva evolution on the simplified upper layer. The first column is the Pva evolution for realization number 1, which has the most negative perturbation. Second column is the control run. And the third column, the column on the right, is the realization with the most positive initial condition perturbation. So first, let's take a look at day 1. We can see that from day 1, the PV values show difference on the northeast side of the loop current. And this is where the West Florida Cyclonic Eddy is formed. So positive perturbation yields strong frontal eddies, and no perturbation and negative perturbation yields weak frontal eddies. And from day 10 to day 20, we see that the Pva signal of the West Florida Cyclonic Eddy, it moves southward along the West Florida shelf, and then penetrate into loop current in different extent. For example, let's take a look at day 20. For the most negative perturbation, we can see the penetration is very weak. And then for the control run, we can see the penetration of the loop current frontal eddy is quite evident. And lastly, for the most positive perturbation, we can see the penetration of the loop current frontal eddy is very remarkable. And on day 30, the loop current is detached in realization 49, and it's nearly detached in the control run realization 25. And there's no sign of detachment tendency in the most positive, in the most negative perturbation realization. So we can see that the initial condition perturbs the strength of the West Florida Cyclonic Eddy immediately in day 1, and consequently it perturbed the occurrence of the loop current eddy detachment, or the timing of the loop current eddy detachment. Okay, another thing we noticed that the first from day 1 to day 20, we can see that the Pva difference over the East Campeche Bank is nearly the same across different realization. But the difference appears, we can see the difference appears on day 30. We can see that the, let's look at realization number 1 on day 30. The Campeche Bank Cyclonic Eddy is moving northwestward along the west edge of the loop current. And so is the Campeche Bank Cyclonic Eddy for the control run. While in the most positive perturbation scenario, we can see that the Campeche Bank Cyclonic Eddy is moving northeastward. It's trying to merge with the incoming West Florida Cyclonic Eddy, which is coming from the northeast. So comparing with the immediate perturbation of the West Florida Cyclonic Eddy, the perturbation of the Campeche Bank Cyclonic Eddy appears quite late. Okay, let's take a look at the statistics of the Pva evolution. So now we can use one of the advantage of the polynomial chaos technique. It helps us to calculate the analytical variance of the model field with regard to the uncertain inputs. So this plot shows the analytical standard deviation of the Pva evolution. So we can see that in the beginning, on day 5, the high standard deviation is mostly located on the north and on the northeast side of the loop current. And then the high standard deviation region, it moves along with the displacement of the West Florida Cyclonic Eddy. And from day 25, we can see that standard deviation over the East Campeche Bank start to show up, which is quite small in previous days. And on day 30, we can see that the standard deviation over the Campeche Bank is quite remarkable. And this agree with our previous slides. So now let's take a look at the initial strength and size of the West Florida Cyclonic Eddy in the random variable space. So we estimated the size and the strength of the West Florida Cyclonic Eddy. The size defined in the surface area of the West Florida Cyclonic Eddy, which is defined by the negative 28 centimeters SSH. And the strength is the integrated upper, simplified upper layer PV of the West Florida Cyclonic Eddy. And so this one is showing the initial West Florida cyclonic strength, which is the strength of the cyclonic eddy on day one over the Xi1 and Xi2 space. And we can see that there's a strong positive relationship between the PV and the Xi1 value. The higher, the more positive the Xi1 value, the higher the PV it will be. Well, on the Xi2 direction, we see that the strength of the West Florida cyclonic eddy is not quite as sensitive with the change of Xi2 value. And similarly for the initial West Florida cyclonic eddy size, it also shows positive relationship with Xi1 value and less sensitivity with Xi2 value. So next, I make a regression between the loop current eddy detachment and the initial West Florida cyclonic size and strength. So the plot on the left is the relationship between the initial cyclonic eddy strength and the loop current detachment occurrence. So you can see the circles in the bottom, which are the realizations without loop current eddy detachment occurrence. And the circles on the top are the realizations with loop current eddy detachment occurrence. And we can see that most of the upper circles, they have a bigger initial West Florida cyclonic eddy strength. And those realizations without eddy detachment occurrence, they have relatively small cyclonic strength. So since the occurrence is a binary variable, we fit a logistic regression in it. So this S-shaped curve, which is also called the sigmoid, is a probability curve of the response. So we can see that with the increase of the initial cyclonic eddy strength, the higher the probability that the loop current detachment would occur. And the story is similar with the initial West Florida cyclonic eddy size and the eddy detachment occurrence. And in both scenarios, I also calculated correlation coefficient. And so the correlation coefficient is 0.88 in the first scenario and 0.86. So both correlation coefficient are very high. So the loop current detachment occurrence is highly correlated with initial West Florida cyclonic eddy size and strength. So generally, the larger, the more intense the initial West Florida cyclonic eddy is, the more likely a loop current eddy detachment occurrence would follow up. And then we can use the size and the strength of the cyclonic eddy as a predictor of the loop current detachment occurrence. And we can see that the sample points, there are only 49 sample points. So we can use the PC surrogates to generate a very large sample size, for example, 1,000, 2,000 sample size to verify the robustness of the relationship. And this would be one of my next steps to verify the robustness of this positive correlation. So in this section, we find that the initial conditions perturb the size and strength of the West Florida cyclonic eddy, and the initial states of the West Florida cyclonic eddy is highly correlated with loop current eddy detachment. And then we can draw state from, we can draw an arrow from the initial conditions to loop current eddy detachment, we find that the initial conditions significantly impact the eddy detachment. So this is what we find of the initial condition perturbation over the West Florida Cyclonic Eddy. Now let's take a look at the perturbation impact on the Campeche Bank. And we take the East Campeche Bank where the Campeche Bank Cyclonic Eddy is always formed. And then we take spatial average PV over that area, and we plot the average PV also in random variable space. Now we can see that different from the West Florida Cyclonic Eddy, on day 5, we can see the PV is almost not sensitive to Xi1 or to Xi2. And similarly, we on day 10, day 15. But since day 20, we can see there are some positive relationship start to show up. And we can see that in day 25 too. And on day 30, the positive relationship becomes most evident. So we can see that with the increase of Xi1 value, the average PV over the Campeche Bank is also increasing. And along the Xi2 direction, the PV is less sensitive to the second Eof mode. So the Eof mode 1, which is extracted from the northern part of Gulf of Mexico, as we've seen in the previous SSH map, it perturbs Pva evolution over the Campeche Bank, and consequently the development of the Campeche Bank Cyclonic Eddy. So the conclusion for this section is the first one: the initial condition perturbed the strength and the size of the West Florida Cyclonic Eddy immediately. And the West Florida Cyclonic Eddy with coherent vertical structure, it either propagated along the loop current eastern edge or penetrated the loop current in different extents. The initial condition also perturbs the strength of the eastern Campeche Bank, where the Campeche Bank Cyclonic Eddy is formed. The perturbation appears later than that of West Florida Cyclonic Eddy. The perturbation of the initial condition on these two loop current frontal eddies on both sides of the loop current consequently determine the occurrence and timing of the loop current eddy detachment. Okay, so my second part of the results is the loop current frontal eddy teleconnection. So in this section, I'm presenting statistical evidence showing the remote connection between West Florida Cyclonic Eddy and the Campeche Bank Cyclonic Eddy. First, let's take a look at the covariance. So this plot shows the covariance between SSH over the whole Gulf of Mexico and the spatially averaged PV over the East Campeche Bank, where Campeche Bank Cyclonic Eddy is always formed. This one is for the realization 49 with the most positive initial condition perturbation. So the PV, so the average PV is on day 30, and the SSH is with different time lag. So for example, 25-day lag is the covariance between the PV on day 30 and the SSH on day 5. 20-day lag is the covariance between PV on day 30 and the SSH on day 10, so etc. So we can see that the in the beginning, in the 25-day lag, we can see a negative covariance start to appear on the northeastern side of the loop current. It overlapped with the front of the West Florida Cyclonic Eddy. And In 20-day lag and 10-day to 10-day lag, the negative covariance strengthens, and it moves along with the front of the loop current of the West Florida Cyclonic Eddy. And in the scenario of 5-day lag and 0-day lag, we can see positive covariance appears in the vicinity of the negative covariance region, which is shown in red. And the conclusion for this plot is the PV growing on the east Campeche Bank is positively related with the strength of the West Florida Cyclonic Eddy and the distance between them. And we can as well see another phenomenon, which is from the initial integrated PV of West Florida Cyclonic Eddy versus the integrated PV of East Campeche Bank from day 1 to day 35. So these circles are the 49 realizations. The blue circles are the realizations with loop current eddy detachment occurrence. And those red circles are realizations without loop current detachment occurrence. So on day 1, we see that the Eastern Campeche Bank PV is already highly correlated with initial West Florida cyclonic Eddy PV, because the correlation coefficient is as high as 0.84. And from day 1 to day 20, the correlation does not change very much. The R value is similar. And on day 30, the positive correlation reached the peak. The R value is as high as 0.94. And on day 35, the correlation decreases, but it still remains very high. So the strength of the East Campeche Bank is highly correlated with the strength of the West Florida Cyclonic Eddy. And we can as well see another phenomenon. So we can see that the blue circles in general have higher West Florida Cyclonic Eddy strengths and higher Eastern Campeche Bank PV than the blue circles. In other words, the realization with eddy detachment occurrence yields higher West Florida Cyclonic Eddy strengths and higher Eastern Campeche Bank strengths than the realizations without eddy detachment occurrence. So we infer that loop current detachment occurs with the requirement of high West Florida Cyclonic Eddy and high Campeche Bank Cyclonic Eddy strengths. And similarly, we also plotted the scatter plot of the initial West Florida size against the strengths over the East Campeche Bank. And the results are similar with the previous one. So when the proper day lapse is chosen, for example, the day 30, the initial West Florida cyclonic states have a very strong positive relationship with PV over Eastern Campeche Bank. And the West Florida cyclonic eddy states can also be used as a predictor for loop current eddy detachment occurrence, as we previously shown in the logistic regression results. So my conclusion for this section is the PV over East Campeche Bank is positively related with the strength and size of the loop current frontal eddy. In general, loop current eddy detachment occurrence requires intense loop current frontal eddies. The size and strength of loop current frontal eddy can be a predictor of Campeche Bank cyclonic eddy formation and the loop current eddy detachment occurrence. So my last result section is the model observation comparison. So we've done a bunch of analysis about the model outputs. Now we want to verify the model reliability by comparing it with observations. Luckily, there are observations that cover the period we study and also the location we are interested in. So in the plot, there are 4 depth mooring in transects northeastern slope of the Campeche Bank. Here from E1 to E5. And the instruments are installed in different depths for each mooring deployment position. And the observations covers from June 2009 to June 2011. So we are going to compare our model outputs with the observation for these mooring stations from E1 to E5, where which are located on the east side of the Campeche Bank, where the Campeche Bank Cyclonic Eddy is usually formed. So to do the comparison, we project the model outputs onto observation positions using linear and bilinear interpolations. And then we compare the velocity that is along the mooring deployment line, which is UT. And also we compare the velocity of UN, which is normal to UT, also normal to the mooring deployment line. So first I'm showing the velocity comparison. And this plot shows the UN velocity comparison between the model and the observation for station from E1 to E5. The magenta, the thick magenta line is observation, and the green and the blue lines, they are ensemble members. You can see that we group these ensemble into 2 colors, the blue color and the green color. The reason we group the ensemble members into 2 colors is the first, the blue groups, it matches the value of the chain of the observation in general. And the green groups, it generally fails to capture the characteristics of the observation. So in terms of accuracy, the blue groups is better than the green group one. And another thing we notice that the ensemble start to bifurcate around day 25. And this is when the Campeche Bank Cyclonic Eddy start to get affected by approaching West Florida Cyclonic Eddy. And now, and the second plot is showing the comparison of UN in the intermediate depths around 200 meters. We can see the results are similar with the previous one, where the blue group, they capture the value or the tendency of the observation, and the green group, they fail to capture the characteristics of the observation. And from the previous velocity comparison, it is shown that the group realizations fits the observation better than the green ones. So let's see what is the setting of the initial condition of these 2 different groups. So this plot shows the initial condition perturbation for blue and green realization groups. So we can see that for the blue group, almost all the perturbation had a non-negative psi1 value, except these 3 realizations. So generally speaking, the realization with non-negative psi1 perturbations capture the characteristics of observation velocity evolution. And the 2 groups bifurcate since day 25. The evolution of Campeche Bank Cyclonic Eddy after day 25 is impacted by Xi1, and is less sensitive to Xi2, which match with the finding in PV distribution of the random variable space. So now we are comparing the relative vorticity, and this plot shows the along Morgan line relative vorticity comparison with observations and resolution 1, 25, and 49. First, the observations we can see in the beginning on day 1, high positive RV is formed near the surface of the Campeche Bank, while in the simulations, high RV formed in the depths, and they are close to the shelf break of the Campeche Bank. And on day 25, in the observation, we can see that the RV structure start to shift eastward, and the offshore displacement is showing quite a barotropic. And in the simulation, the deeply intensified RV is lifting to the surface. And we can also already see that the RV snapshot of resolution 49 is quite similar with RV snapshot of observations. And finally, on day 30, we can see that in the observation, the RV structure start to shift. The displacement of positive RV is larger in the depths and gradually becomes smaller when it's close to the surface. And this is similar in the resolution 49. And we can also see that the core in the observation is near the surface where the RV is highest, and it's also the same for resolution 49. The core is near the surface over the Campeche Bank. So the conclusion for the final section is the realizations with non-negative Xi1 perturbations capture the characteristics of observation velocity evolution. Campeche Bank Cyclonic Eddy in observation is originally surface intensified over Campeche Bank, while in simulation it's formed from the depths. And during the Campeche Bank Cyclonic Eddy offshore displacement, the model realizations, especially realization number 49, agree with observation reasonably well. So the conclusion summary is, the first one is the initial condition perturbs the West Florida Cyclonic Eddy immediately, and perturbs the perturbs the Campeche Bank Cyclonic Eddy later on. The perturbation of the loop currents from eddies consequently determines the occurrence and the timing of loop current detachment. The second conclusion is West Florida Cyclonic Eddy's behavior remotely affect the evolution of Campeche Bank Cyclonic Eddy. Thirdly, the size and strength of West Florida Cyclonic Eddy can be used as predictor of cyclonic strength of Eastern Campeche Bank, and also can be used as a predictor of loop current eddy detachment occurrence. Lastly, the model simulation differs from marine observation about the initial formation of Campeche Bank Cyclonic Eddy, while the model captures the characteristics of a Campeche Bank Cyclonic Eddy offshore displacement. So my future work includes the first one. We are going to use the PC approach to efficiently generate a significant number of samples to verify the statistical relationship between the cyclonic frontal eddies and the frontal eddies with the loop current, with the loop current eddy detachment occurrence. And secondly, we are going to seek the physical explanation for the frontal eddy teleconnections, because in the we only show the statistical evidence that the frontal eddies are remotely connected. We haven't found the physical explanation for that yet. And the last one is we are going to verify the teleconnection on other loop current eddy detachment events. Okay, so this is my seminar presentation.
Thank you so much, Xingchen. Does anybody have any questions about the presentation? Brian, it looks like you have one.
No, I was just clapping, you know, unmuted.
Okay, you can either call out or you can submit a question in the chat and I'll read them out, whichever you all prefer.
I have a question, Xingchen.
Yes.
Can you remind the audience how you defined the size of the eddies? Well,
Okay. Okay, I think I explained it. So I use the negative 28 centimeter SSH at the edge of the frontal eddies.
so when you do your dynamical analysis, are you going to do it in a moving reference frame so that you're always in the eddy?
Yes, let me go back to the, yeah. This is how I define the edge of the loop, cyclonic eddy.
So since you're on this figure, what is more important, size or strength?
Well, so in this plot, we can see that both of these two, let me go to the, yeah. So in the plot, we can see both of them are important and their correlation coefficient are quite similar. But I would say the size is more important because the integrated PV is also a positive correlated with the size, right? The bigger the size, the larger the integrated PV it will be. So I would say the size is more important to the loop-grand eddy detachment occurrence.
Does anyone else have any other questions?
I have a general comment.
Okay.
Actually, you kind of answered it at the end of your talk because I was thinking I would put less strength on saying that the east side, the frontal eddy from the east side is actually first, and then the Campeche Bank, because you are actually looking just one case.
Yes.
And there is many papers referring to different way, right? So that I mean, actually, there was a talk a couple of seminars ago by Luna, and she also showed a connection the other way around. So I mean, some cases yes, some cases no. So I don't know which one is first or so that's the first comment. And the other comment is actually that I wouldn't put that a strong statement about that the frontal eddies are directly connected to the detachment or not or maybe because maybe the other way around. I mean, you can have detachment of the loop current eddy without frontal eddies, and you can have it with 1.5 layer, and the big eddy will detach anyway without the small ones. I mean, I know it's a combination of things, but I'm just saying that maybe there should be like a tone down of the, in the sense that this is the only mechanism or the main mechanism, because I mean, I don't think if you can get the detachment with simple physics, I wouldn't say that it's exactly because of that, right?
Yeah.
So so
I also read papers saying that there are many mechanisms that affect the loop current eddy detachment. Yeah, the frontal eddies are one of them. So there are similar events there are similar events with frontal eddy, frankly. For example, Ekman. That's what I read from previous paper. And also there are different events like the, sorry, I forgot. So yeah, the next steps I'm going to investigate other, other events to see whether this one is just unique for this event or it also happens to some other events. I'm not trying to generalize it to all the events that this is the case.
No, I understand, but like when you start, I mean, I can see that at the end of your talk, but from the beginning, it was like, it was less clear to me that, and I thought you were implying that, but yeah, I can see from your last slide or that you are planning to see this in more. And the other comment is about the comparison with the observations. So this comparison was done on the stations on Campeche Bank, right?
Yes.
Okay, and what about the other stations that are more to the middle of the Gulf, like on the loop current? I don't remember the, have you done anything there?
Yeah, we were trying to compare the observation like up north, but I think it will miss this morning station that means the penetration of West Florida Cyclonic Eddy.
Oh, okay.
Actually, the penetration lies south of the those bunch of mooring stations is here. Yeah, so they don't quite capture the penetration of the West Florida Cyclonic Eddy. And so that's why we choose these ones.
So, I mean, and the other thing is in terms of comparison with the observations, it will be useful to see in a similar way, like using the altimetry, like abysso maps, the same process in the way, because I mean, it's of course it's nice to compare with the moorings, but the process of seeing first the frontal eddy and after the Campeche Bank eddy, you can actually check that also on the altimetry data, right? And the other thing I was curious about, it was the differences in the vertical structure at the beginning between observations and model. That I don't know if how relevant is that, but looks more to the surface in the observations than actually in the model. So, okay.
Anyone else have any other questions? I don't see any in the chat, so.
I just would like to say thank you to Xingchen. I have to run to another meeting, but
okay,
those are nice results. I agree with most of what Josefina just said to put the study into context, and we'll have a chance to discuss that further. But good job, Xingchen.
Thank you, Matthew. Thank you, guys.
Yeah, nicely done. I think that that's all of our questions, so we can wrap up then. Thank you everybody for attending. I believe this is being recorded, so this should be posted at some point. And with that, I hope you all have a good Friday and a good weekend, and thank you again.
Thank you. Thank you for attending.